We've been expecting you. Go ahead.
Hello, stranger. How you doing? Let me explain how this rocket works. Let's start off with the fins. These are commercially bought. This is a commercially bought fin cap. Now, check this out. This is a little something we devised for competition a couple years ago. Essentially, since this rocket is minimum diameter, we can't have through-the-wall fins. So, we basically bolt the fins on to the motor case itself with friction. That is then threaded onto this. This is a coupler, which then gets bolted to the rocket with these through-the-wall holes right here. Now, moving on up. In here, the shock cord and the main parachute will be held. This is the E-bay. More on that later. It's held to this section with shear screws. And this here is the upper part of our rocket. This is where the drone's going to be. Moving on up again, this is the nose cone. This is where the drone's going to be. So, show you how the rocket's built. Let's talk about how it performs. Now, the reason why we built a completely new rocket is because we're going to go up on someone's level 3. Turns out it's way too heavy to build something completely new. Length of 120 inches, mass of about 33 pounds. L952. It's going to get to a max apogee of about 8,700 feet at Mach 0.74. Now, look at the stability right here. You may think that's high. This is actually very misleading. Because if we go to the Excel sheet for stability, and if you scroll down to when it gets off the rail, it's 1.5 off the rail, which is very good stability to get to fly and with.
Oh, I didn't see you there, Jenny. What you working on?
That's a great question, Rob. So I'm working on an electronics bid, and how this works is that at the competition, once we have this set at the launch pad, we're going to complete the circuit, which will power on the battery and power on the strutologger. And how the strutologger works is that I programmed it to deploy the drogues at apogee and 1 second after apogee. And then the main at 1,100 feet and 900 feet. And so how that works is that at those certain altitudes, the battery will send an electric current through the entire E-bay and send the current to the electrical starters, which ignites the black powder and then deploys parachutes.
Oh, I didn't see you there. This is the frame for the Sabo. It's how the drone is going to be deployed from the rocket. So if the drone is just deployed on its own, it's likely to become damaged in some way, either from being exposed to the black powder charge directly or from bumping into something on ejection. And the other issue is we don't know, if all you do is eject the drone, you don't know what its orientation is going to be. And drones don't work when they're upside down. So with the Sabo, the drone inside, there's going to be other components involved. It will protect it during ejection, and then there's going to be a parachute which will correct the orientation before you release the drone.
Hello there. My name is Ronald. I am in charge of the drop mechanism for the drone and for the electronics, some parts of it. For the drop mechanism, what we're thinking is a latch, which is a regular old door latch, that is going to be moved by a rotating servo, that is going to be powered by or signaled by a Arduino Nano, which are still coming in, but we're also using a BMP280 as our altimeter. Right here is a little bit of the wiring just to figure out how to reduce the voltage so that our servo can run it, because usually this is a 9 volt, we wrote it down to about, I don't know, it's like 6, 7 bolts. So pretty much all just testing phase. We're still figuring out the code. Also figuring out the format of the plate that we're going to attach to the Sabo. And yeah, I'll see you guys when we finish.
Hi there, my name is Philip Corris and I am in charge of the drone which will be deploying the payload for Argonia. We decided to go with the drone because it is, simply put, simpler, because drones are better with GPS. Our intentions are to have the GPS coordinates of the drop location of where the golf ball is supposed to be, program it into the drone, and have the drone fly there. The logistics of releasing the drone is being covered by my team members Ronald and Robert, who will be, the drone will drop roughly around 100 feet above the ground. It will activate and it will fly to the location. This drone is an FPV drone. We are modifying it with extra parts for it to work for our causes. We've had some troubles with that, hence why it's not currently functional. We have GPS working and everything. The last real step is to get the receiver working, and hopefully we'll get that soon. And yeah.